So just a quick review of what we did last week. Last day we looked at how to represent a complex number. Right? We said a complex number could be written in the form x plus iy, right? X is the real part. Real part. So sometimes, I'm not sure if I give you this notation, but if you see RE of Z, they want the real part of Z, which is X. And here, this is the imaginary part. So if, for example, you see M of Z, they want Y. Right? So complex numbers are generally of this form. Right? If you see RE means real, if you see IM means imaginary. Right? We looked at adding and subtracting complex numbers, add the X, add the Y, minus the X, minus the Y, and so on, right? And after that, we'll talk about the conjugates. What's the conjugate of this again?
X minus iy.
Right? X minus iy. Right? One thing I wanted to note, I think I just show you one example, but we didn't officially write it down. What is Z plus Z hat? I showed you what was multiplied. What is Z minus Z hat? Look at Z and look at Z hat. What is Z plus Z hat?
Z. X.
2x, right? If I were to add in Z and Z hat, X plus X is 2x. This will cancel. See enough? So you will get 2x, or you could write it as 2 by the real part of Z. Okay? So it's always going to be twice whatever the real part was. Remember what is Z minus Z hat now? 2yi, which is what? Which is 2 by the imaginary part, right? And to be totally body out. Right, so these were some of the things that we did, and then we looked at how to find the square root of a complex. Why do you giving it one something? Wait, so just see this? Huh? You just come back all to class. One second. Why does it on right again? My son up there? Well, it's up to you, but I'm gonna poor help you, man. I don't get to help you. All right. Okay, so these are some of the things that we did, and then we looked at how to find the square root of a complex number. Today, we're gonna take a look at how to take this complex number that is in the Cartesian form and convert it to the polar form and the exponential form. All right. But in order to do that, we need to start something called a Argand diagram. Right? So complex numbers can be represented by an Argand diagram. Right? We're gonna spend some time on this Argand diagram. Right? We check out the variables, right? Right? Alright, ready? So a argon diagram, right? An argon diagram, just like plotting a coordinate, is a way for you to represent a complex number in a 2D diagram. Alright, so if we have z is equal to x plus iy, and I want to represent this on an argon diagram, normal 2D diagram, right? A normal 2D diagram where the x-axis represents the real part and the y-axis represents the imaginary part. Right? Same scale like 1, 2, 3, 4. 1, 2, 3. All right. So for example, if I wanted to plot this point, I'm going to plot x and plot y. So let's pretend here is x. Let's pretend here is y. So when I plot it, I'll get z. Z is right here. Are you okay with that? But z has two components. Z has a magnitude, right? We call it modulus of z. And z also has something called an argument, which we measure from the positive x-axis. This is the argument of z. So if we know the modulus and the argument, we know exactly where z is. Are you okay with that? Yeah. So how do we find modulus, right? So the modulus of z is the square root of its x value squared plus the y value squared. So the square root of the real and the imaginary part, right? That easy, right? Tricky part is the argument, right? Copy this down and let's spend some time on the argument, right? Get the calculator, right? Are you okay online? I'll show you an example with numbers just now, right? Are you okay? That's not. Argument of z. We have 6 rounds. Last we do one, right? Hi, ready? Oh, you'll join us. Ready? Are you ready or yes, sir? Ready, Tabitha? Right. So, what's the argument, right? Right. So the argument basically is the angle that the complex number makes to the positive x-axis. Okay. So the argument is any angle here, right, from the positive x-axis, but there's a slight problem with the argument, right? The argument can only fall within the range minus pi and pi, right? So if you were measuring from here and you go come all the way here, what's that angle here? Pi, right? But what will happen if the point is down here? It'll go more than pi, right? In a case like that, instead of going with anti-clockwise, instead of going anti-clockwise, you measure it clockwise. That's okay? Because you want to always end up within this range. So, two things we need to know about argument, three things. But first thing that we need to know about argument is number one, we must see that the argument is measured from a positive x-axis. Number two, right? The argument of z always lies between minus pi and pi, right? And I want you to remember that if you're measuring anti-clockwise, that's positive. If you're measuring clockwise, that's negative. That's okay? So your argument is positive clockwise and negative anti-clockwise. Okay? Sorry, anti-clockwise is positive, clockwise is negative. Right? And how you find it, the argument of z is tan inverse the y or the imaginary part over the real part. That's the way you find it, right? The imaginary part over the real part. All right, so here's the problem. What you say earlier. Here's the problem, right? This formula works nicely when the complex number is in the first quadrant or the fourth quadrant. It works nicely, but it doesn't work when it's here and here. So the formula has to change slightly. When in the first quadrant, the argument is tan inverse y on x. When it's in the fourth quadrant, is tan inverse, right? And I'll show you why just now when I give you some numbers, right? But in the first and fourth quadrant, this works nicely. In the second quadrant, we have to change the formula a little bit. We have to take pi and minus that tan inverse value. Right? Sorry, this one is add. Sorry. Add pi to it. Anybody remember if tan is positive or negative in the second quadrant? Second.
All school teachers class.
So it's negative, right?
Positive.
No, tan negative here, right? So what will happen in the second quadrant is this will be negative and you'll have to minus it from pi. In the third quadrant, tan is what? Positive. So now you're taking minus pi and adding it to. The reason for this is that you want the sign to be correct. You want argument to always be negative down here, positive up here. Okay, so I'll give you some examples on how to work it out now. Right? So in short, the two things we're looking for is how to find modulus, real squared plus imaginary squared, square root of that, and how to get the arguments. Plot it, figure out which quadrant it's in, and then use the right formula. All right? Let's try some easy examples. Let's try some examples here. All on the Argon diagram, right? You want to plot on Argon diagram. Online, you got okay so far? So we're going to take this and we're going to get its modulus and its argument. Right? We're going to get its modulus and its argument, right? Yeah, well, okay, nice. Everybody watch this. I want to show you how to work it out, right? Actually, I'm taking out the plus, put minus instead. Right, Shibish, what you say? So when you come on the board, you'll get it right. All right? Because here, good. Right, ready? So what you say, Olive? First thing we do is we just plot it, right? So you're plotting x is 1, y is minus 1. Right? So x is 1, y is minus 1, somewhere here, right? That's okay? So you need the modulus. The modulus of z, real easy, square root of 1 squared, square root of 1 squared plus minus 1 squared. Right? That's 1 plus 1, that's 2. So the modulus is square root of 2. Right? Where would the argument be? Which quadrant? Fourth, right? It's in the fourth quadrant. So should I measure this clockwise? I mean anti-clockwise or clockwise? Clockwise. Right? Because anti-clockwise is more than pi. You're saying that? So I'm supposed to get a negative argument. So let's make sure argument of z is tan inverse y value, which is minus 1 over 1. Plug it in just like that in the calculator. Read the answer, read the answer. Pi on 4. Yeah? Right, negative pi on 4. So it's negative pi on 4. So your argument here is negative pi all over 4.
Right?
Yeah.
That's where I followed.
That's the modulus. That's the length of the line. Okay? So the modulus is root 2 and the argument is minus pi on 4. Are you okay with that? So you'll see why we need to pay attention to how we find the argument, right? So always remember, yeah, adding to pi here, adding to minus pi here. Right? Any questions online? So now we know its magnitude and its location, like a vector quantity. We know its magnitude and direction, right? Right? Online? Are you okay with that? Yeah. All right, let's try the next one. Let's use easy values, right? Let's use z is equal to minus 1 minus I. Find the argument and modulus. Hmm? All the time we will use the calculator. X and Y is Cartesian, so we're gonna change it to polar form. Ready? Well, I got you right. Right, so first thing we do, we plot it. Right, plot it quick. Argument is here. Modulus is the same root 2. Same root 2. Right? And the argument of z is in the third quadrant, so we're using minus pi plus tan inverse minus 1 and minus 1. That will give us minus 3/4. Yeah? Right? So we get minus 3/4 pi. Okay with that? Right? Here's what you're doing coming out. So if z is 1 plus I want you to find this amount. I want you to find the modulus of z multiplied by z hat. Right? Tell me what you get. And then I want you to find the argument of z by z hat. Right? Z hat what again? Right. Try that from it. Let's see what you end up with.
Okay, you can see a balance.
using one plus I.
How is plus I would go to minus I?
Huh?
Plus I, right? Okay. Oh, wait, I answer.
Yeah. But look what I want, huh? Look what I want. Actually, I should break it up for you. I'm gonna just break it up for you. Sorry. Right? I can change it. I will change it slightly. I'm gonna change it slightly because I want you to get a few things from them. So I want you to get the modulus of z, the modulus of w, and then the modulus of z by w. Forget the argumenting. Right? I want you might be able to see it easier here. Then find the argument of z, argument of w. Just a few more parts to be quite easier, yes. Argument of z multiplied by w.
Rather, basically, finding two arguments and then one later.
Which one?
Let's see, we find the argument, the same argument, right?
Yeah.
The argument, the same.
No, find z by w. And then find its argument. Right? So here you're finding z by w, then finding the modulus. Here you're multiplying z by w and then finding the modulus. And I want to show you something after. Take your time. I have to be multiplying z by w. But I gotta rotate, right? Yeah. Well, I got that to C by W. Why? Right, so what I wanted to do here is to find its modulus. So you're finding modulus of Z by W. Right, so it'll be the square root of 0 squared, because there's no X here, right? There's no X here, right? 0 plus 4 squared, and again 4. Are you okay with that? And then, where does this belong?
My. So by even a square.
This go? So much though. Right? So look at exactly where it is. Look at exactly where the point is. What's the argument? What's the argument here?
0.
What?
Everyone 0 anything.
What's the argument here? 5 and 2. Right? So the argument of CW is 5 and 2. Remember? Look at where it is. It's on the y-axis. Right? So here to here, 5 and 2. Okay? You recognize that? Right. But no, Shirish? What? How I get 5 and 2, Shirish? Huh? Yeah. How I get 5 and 2 here? How much is here to here? 5, right? So halfway is 5 and 2. Right? So the argument here is 5 and 2. So don't go take calculator and panic. Yeah? If you go to a calculator, you'll write tan inverse
1 0. 1
410, right? Undefined. Well, we know where tan is undefined. Pi 2, right?
Oh, so the new from.
From here, from trace. Right. But here's something I want to recognize, right? Anybody seen a pattern? Anybody seen a relationship? Sorry, not pattern.
Yeah, I don't know. 4 every time.
Right? Very good. Right? So if you were to find the modulus of z by w, really and truly it's just the modulus of z by the modulus of w. You recognize that? Multiply two of them. Multiply root 2 by root 8. You'll get root 16, which is 4. Right? So it's a root to learn. Right? Next. Argument of z multiplied by w is the argument of z plus the argument of w. Pi on 4 plus pi on 4 is pi on 2. That's okay? Yeah? So Ariane, what do you think about this? What do you think the rule will be like for this? What do you think the rule will be like? What do you think? Anything? Oh yeah, so what do you think, Ariane? It is the equation. Yeah, so what do you think, Ariane? So the modulus is what? Modulus of z divided by modulus of w1. Argument of z minus the argument of w. Right? So it's a real useful rule because sometimes, like, I'll give you one in a little while. Sometimes you'll recognize that doing this real hard and then working it out. Right? So it's easier for you to find z and find for w and then use the rules. That's okay? Copy it down. Any questions online, Mikhail? Yeah? Yeah. Huh? No, that too. Not much. That's not true. Forget that. That's a good. Right, but oh yeah. But when we do an argument, we have to make sure that the value we get to the argument within the range. Yeah? I'll give you an example where it's not in the range and I'll show you how to fix it. Copy down. So you can use this rule here now. Remember, your feet ahead of mine, so who? Your female fire, I know reach 27.
I'm putting myself.
Think about that. No, no, I don't think it's good time, man.
I, you know. I don't know.
Right. Everybody right to that? Amanda, you're okay online? Yeah, all right. Let's try this one here now. I'll write it, right? So you have the screens. You get it?
Yeah.
Penalty. Find the argument of Z2 and Z1 here. Please use the roulette, don't go and divide it out, right? So you recognize what will happen here? If you have to divide two of them, how chance it becomes the root something? Right? So that's why the rule is much easier, right?
It's possible.
No, just go ahead.
No, you
Take your time, try that there. Oh, on. Hello, or silver. He did not there.
It's in the alliance.
Yeah. That's the one of yours. You think about it.
It's one thing really, that's. You really don't do it, that you ask, so you put. It's already graph, you look at the
Huh?
It's already graph, you look at
No, no graph ready. No, I did that, but the graph is just a highlight what quadrant is it. So you don't have to show the graph. It's just important that you highlight where it is. Not bad. Online, when you change the message answer, so I will get out. You run into the out two boys. I think all the emails there, you'll have to go onto the element. I even want to add a bit of. But if it's not a more detailed. Put up every single. All right, let's see how it went now. Let's see how this went here. Right, as I said, we don't want modulus, we just need argument. There is no need to plot it actually. You just have to know which quadrant, third quadrant, so we're using tan inverse y on x. How much is this? Pi on 3. And then you have argument of z2. This is minus x positive y. So that is in the second quadrant. So that's pi. That's pi plus, right? Pi plus tan inverse 1 minus 2. How much is that? 3 pi on 4. Nice. So what they want? They would like you to get the argument of z2 over z1. Right? The argument of z2 over z1 divided. So we're going to subtract argument of z2 minus the argument of z1. So that's 3/4 pi minus pi on 3. How much is that? That's what, 9 minus 4? 5 pi on 12. So that's 5 pi on 12. Okay? So that's the argument there. 5 pi on 12. Everybody okay with that? But before, what you say earlier, before you accept the answer, you have to make sure it falls within the range. Okay? Does this fall within the range? Yeah. So you're good to go. All right? What if it doesn't fall in? I'll show you that. Ready? Right. Let's take a look at this here. This basically came for 6 marks, no, 4 marks in 2019. Right. Let's look at this situation here, right? Let's use that on top. Right. Let's look at this example here. There's a special case, right? This is a special case that we have here. Right? Let's see if we could find. Let's see if we could find. What number is this? 3? Huh? 5. Let's see if we could find the argument of z to the power 7 if z, I use the same one here. 3 plus 3i. I'll give some ideas here. How are we gonna prove something like this? To the power 7. And I'll tell you all what you all can develop it after that.
Then finding out if this.
Add them 7 times, right? Because you're multiplying by z 7 times, so like adding it, right? So therefore, the argument of z to the power 7 is equal to 7 times the argument of z. Hello, give it up. Why you laughing at the bishop? All right, you see? There's a 7 and there's a z. Look it up. Right? And we know that the argument of z, we worked it out already. The argument of z is 5 and 3. That's okay? So therefore, what will the answer be? What's that matter? That? Like it. Yeah. Oh. Right?
Yeah, she didn't want to say
Right? So watch this here. It will be 7 multiplied by 5 and 3. But we have a slight problem. 7 pi and 3 is outside of the range. So here's what you're gonna do. You need to find the equivalent of 7 pi and 3, right? So we need to find a way to get the equivalent of 7 pi, right? Within the range minus pi and pi. All right, that's really important that you wasn't paying attention. Pay attention now. Right, Shivish, pay attention. How are we going to get the equivalent? What you say? Right, so what's the equivalent of 7 pi on 3? 7 pi on 3, let's just break it up. 7 pi on 3 is 2 and 1/3 pi, right? So 7 pi on 3 is 2 and 1/3 pi. Have you cleared up? Well, 2 pi plus 1/3 pi, right? Right, so what is here? How much is this? How much is this? 2 pi, right? So 2 and 1/3 pi might be somewhere right there. Correct? 1 pi, 2 pi. So 2 and 1/3 pi is all of this here. All right? But if we were measuring from the positive x-axis, how much is that? Pi on 3. So 7 pi on 3 is equivalent to pi on 3. Not really, because it could be 14 pi on 3.
Yeah.
So you had to check on the side. Yeah, you had to mind for this side. Are you okay with that? Right? So I went pi, 2 pi, pi on 3, and then where you stop, measure it from the positive x-axis. Okay? Yeah? So therefore, the argument of z to the power of 7 within the ranges 5. Go ahead. Copy it down. Online, are they okay there? Samira? Oh, we'll go. Yeah, we'll have to show the slide. Because that's a lot of things. Every time you reach your book. And it when I pay it on. You wanna. Okay, so we have 200. But she did the same aspect of it. That's not it. Is that wow? That's yeah, yeah. We don't literally, you know, that's from there, so we never leave less and less better. Yeah, not for that sheets. What don't shit. My head, you get some devils. We didn't like that. Yeah. Yeah, no problem. Then I give like these to the players. Yeah, so we go down. I mean, I think it's 16. Ready? Yeah. All right, let's try 2019. Let me write. Let's try 2019. Everything finishing this weekend? Euros on. Yes, I can. Yeah. Remember everyone is fine already. It's not in eight. Fix. Try that there, find the argument of z and the modulus of z. Then I'm going to show you all something that you just felt.
Yeah.
Finish? And define equivalent, right? Why, you not break it up, because it's because seven, Yeah, ready? Let's check it out. So first thing, let's find the modulus of -1 plus √3. Right, the modulus of this is the square root of -1 squared plus √3 squared. So that's 4, so you're getting 2. So therefore, the modulus of z will be 2 to the power of 7. If we use the formula I gave you, right? What is that? 1 point. That's okay? Are you okay with that?
Yeah.
So I found the modulus. Remember, this is not z, yeah? So what's your notation, right? So I found the modulus of this, which is 2, and then I find 2 to the power of 7. Okay? That's the first one. What one, Azaria? What are you complaining about? What you do? Remember, if it,
Yeah, we got like.
oh, argument now. So you need to find the argument of -1 plus √3i. Right? That is in the, which quadrant is that? Second quadrant. So that will be pi plus tan inverse y on x. How much you get?
500. No, well, you give me 5 plus the 5.
2 pi and 3?
Yeah.
Right. But what do we need? Right? We need the argument of z, which will be 2 pi on 3 all multiplied by 7. Okay? That's the argument of z. Remember, z is all this to the power of 7, right? So that'll be 14 pi on 3. But out of the range, right? So what do we need? We need the equivalent of 14 pi on 3. Remember, 14 pi on 3 is how much? It's about 4 and 2/3 pi. So you go in. So that's 4 pi plus this, right? 1 pi, 2 pi, 3 pi, 4 pi, 2/3 pi. Right? So that's 2 pi on 3. So 14 pi on 3 is equivalent to 2 pi on 3. You cannot just write this and get the answer. You have to show them all of this. Okay? And you have to show them how come these two, how these two equivalent, right? Yeah, you have to show them the cycle method.
Okay, Gabriel.
So, are you okay with that? All right. All right, take a 5-minute break. Oh, let me go. What if we don't get possibly?
Wow.
I take a 5-minute break and then we start back with polar 4. You're sure you're not going? Wow, right, we'll look at polar form after, right? One thing I never realized. Is that anybody likes you reaching out loud? You have to practice. All I want to teach you. So come on, you ask. 5 minutes up. Alright, let's start with it. Right out. Right here. Alright, head up polar form, polar and exponential form.
Polarization.
Polar and exponential form. What do you have for that? Oh, it was doing play, Jasu. It was some little good victim. Some little good victim and you get real vets. It's good.
Oh.
Yeah, but I think I don't give the teacher though, not actually the money. See, I do it. Hmm?
No, just very cool.
Right, so the next thing you want to look at, polar form, polar and exponential form, right? Amanda, reach back. Right. So we want to take a look at polar and exponential form, right? So if we have z x plus iy, this here is our Cartesian form, right? Z is equal to r by cosine theta plus I sine theta. This is what we call our polar form. Right? This is what we call our polar form. And then z is equal to re to the I theta. This is what we call our exponential form. Right? Where r is the modulus and theta is the argument. That's okay? So if you need to convert to polar form, you just need r and theta. You want to convert to exponential form, you just need r and theta. That's it. Ready? Come on, already, right? Coming up, I want to show you how to get it polar form and how to get it. Right. Right, ready? So what do we need? So in order to take the Cartesian form -1 plus 3i and write it in polar and exponential form, we just need r and theta. Right, we did this one already. R is what? R is 2 and argument is 2 pi on 3. You okay with that? So therefore z is what? Z is 2 open brackets cosine 2 pi on 3 plus sine 2 pi on 3 I. Right? All of it are just plug in theta now. Right? And here here is what? Here will be r, which is 2e to the 2 pi on 3 by I. Right? If you put this in the calculator, you'll get that. Like multi. Huh? No, we'll just put this on this now and you'll get that. Okay. But you have areas. If you find 2 cosine 2 pi on 3, you'll get -1. If you find 2 sine 2 pi on 3, you'll get root 3. So again, back the same form here. Hmm? No, that is right. You want to use the expansion. No worry about it. The exponential form is different. So guys, you'll see these two are the same, right? All right. You guys? Well, get online too. Rihanna. Yeah, Amanda. Everybody clear up? All right. So there's one thing I want to show you. You gotta remember that fun looking word from Monday, demorphs. Yeah. Right. I want to show you how demorphs came up with the theorem, right? Watch this here. Right? Watch this here. Suppose I said, write this in polar form. Suppose I said to write this in polar form. What would the answer be? What would the answer be? Huh? It'll be 2 to the 7. Right? Just like what we had there. And this will be this multiplied by 7. Correct? So this in the polar form is really this. Correct? Just take this 7 and put it here and here, and well, by the modulus. Correct? Huh? And the exponential, you're putting 7 here. And 2 to the 7 is the modulus, 7 by this is the average. But of course, you have to simplify it and simplify it like this. Right? But anyway, so here's what De Moore basically said. The De Moore said that if I gave you x plus iy to the power, sorry, I'll give it a note just now, but if De Moore said, if I gave you cos theta plus I sine theta to the power of n, he said that this is the same as cos n theta plus I sine n theta. Now see that? So he said that these two things here are equal. All right? You're seeing that, right? Okay, so that's the principle behind the Morse theorem. I'm not going to rush into that because we'll have to learn something called binomial expansion rule.
Yeah.
I'm going to give you a video and I'm going to do that.
Better than himself.
Can you be able to expand it?
So I can ask.
All right, let's do a few of these now. Let's do a few of these. Right, in the polar form and the exponential. Let's see if I can put it up here. Did I give you -1 plus I to the 7 already? Okay, everything is 7. Well, and I'm not going to change every number next year, right? So. All right, goodbye. What is 7? Ignore part C. We just do in part D here. This one here, right? Forget this here, right? Right, so write the complex number in the polar in that form, and then prove this amount. Prove that. That is 20 something.
That makes solution, please.
I'll give you. Next year.
See. We didn't get it.
Of course, that was syllabus that area. The unit 2 book. So copy. Must have one something. I think I have one. So somebody can it out. Huh? It just be a little challenge. But it's the other one more group. That's good.
Yeah, I get those to be everything was there.
A little more.
Yeah. If you know, the real world. I think you like one time, that's fine.
You don't want to come up. Now you go down to the box to the point. Right, so find it in what form is this here, Shivish? R exponential, right? And then prove this. So you have to prove this equal to this. I'll give you a little hint. Polar form will help. Go ahead. You have skin. Same thing, always, always. Part one or two. Okay, now. Put it in polar in exponential form. Part two, you will need polar form. Are you done? I already even start with. That's a I. Here, that's a I. And an R and E and a theta. Oh yeah, find place, make form and then that's part three down. Right, for your homework, you have to look up how to do binomial theorem. If you look on the channel, there's a whole video on how to do binomial theorem. Shivish, you in charge, right? Make sure they can explain how to do binomial theorem. You in charge.
Seven. I need a number three more. RZ.
R is modular. Yeah, but then polar form and you have to figure out next. Don't do this one. That's 2030. We're doing this 2030.
Yeah, absolutely. Yeah. Yeah, we can write it. Go right from this side, so you'll get high plus right. Physics.
Right, what's the modulus of minus?
Yeah. Yeah.
Right, what's the modulus of this? Root 2, right? And what's the argument of minus 1 plus I? Right, that's second quadrant again, right? Nice. So that's it. You done?
Yes.
Oh, yeah, to the power 7. So now we need to get the modulus of z, which is root 2 to the power 7, or you could write it as 2 to the 7 and 2.
So we remember, right?
And add, yeah,
It's pretty cool. You know very good, right?
yeah,
Is that 7 multiplied by 2 times 3?
yeah.
Or plus 3 power 7?
Which one? Polar form?
Yeah, 7 by the graph.
7 by the graph.
We put it into the, we leave it as the big value to get together.
But it will give you the same thing. But remember the equivalent value, right? Right, anyway, the argument of z will be 7 multiplied by 3 pi on 4, which is 21 pi on 4. We have a slight problem out of the range, right? So 21 pi on 4 is what? 5 and a quarter.
Yeah.
So 5 pi plus a quarter pi. So let's go 1 and it's positive. If it were negative, it would be the other way, right? 1, 2 pi, 3 pi, 4 pi, 5 pi, and a quarter. So it's 8. Right? So please remember, if you take a measurement from the positive x-axis in that direction, what will happen? It will be bigger than the range, right? So you have to actually take it the opposite way. From the positive x in the clockwise direction. If here is pi on 4, then here is minus 3 pi on. That's okay? So therefore, the equivalent to 21 pi on 4 is minus 3 pi on 4. So your final answer will be z is equal to 2 to the 7 on 2. Or you can write root 2 to the 7 by e to the minus I 3 pi on 4. Leave it like that because here you will need it. You'll need the exact value to figure out part 3. Right? So what is the polar form? Shivish, what's the polar form? What would the polar form be? 2? No. Okay. It's minus 1 plus I to the power 7. Right? So it will be 2 to the power of 7 on 2. Open brackets. Plus. What's the angle? What's the argument? Minus 3 pi on 4. In this case, if you're right, 21 pi on 4, you get the same answer. But technically it's wrong because argument has to be between minus pi and pi. Okay? Plus I sine minus 3/4 pi on 4. What do I do now, Olya? Right? What are you going to do now? Huh? No, and I mean, do it already.
No, that's not like, oh, that's 7 by brackets. 7 by brackets, it's 7.
Yeah, so you work out, so you worked out the argument already. You worked out the argument of put this up here,
7, it's perfect.
right? Though this part in blue when I was kind of showing it, the Morse theorem, right? So Azaria, hold on, do that now. Also, what to do now? How do I turn my part in red to that minus 8 minus 8 by 1 plus I? Or again this here.
Wait, about into the.
That's all you how to get the Cartesian from right here. Just put in the calculator.
Yeah,
Yeah, when multiply that, put it in the calculator. See what you get. Well, follow it. Online, you'll follow it. So all we're gonna do now, is we're just gonna take this here, multiply by this, that'll be the real part. And then take this here, multiplied by this, and that'll be the imaginary part. Right, tell me what you got for Z. Well, for this here, which is take your time, right? If I work in radians, right? What y'all got? Again, sure. How much you got? Minus minus 16. Where you get minus 16? What you got? Right? So when we reach here and you put it in polar form, right? In polar form, it will be 2 by what is it again? 70 root 2. Right? 7 root 2 cosine minus 3/4 pi on 4 plus I sine minus 3/4 pi. Keep the minus sign inside there, right? And then in order for you to work this out, you have to multiply it out, right? So you're taking 2 by right? So you're taking 2 to the 7 on 2, and you're multiplying it by cos 3/4 pi on 4. Work out this in the calculator. That'll be a real part. And then you're doing the same thing here. 2, 7 on 2, sine 3/4 pi. That's the imaginary part. When you work out, this is supposed to get minus 8. Yeah. Yeah? Minus it again. Minus 8i. And then you factor out the minus 8 and you get it. Right? So this going straight in the calculator. Right? You check and see if you put 2 to the because check and see if you put 2 to the 7. Okay.
So how marks that one? Because
That's 3 and 6.
the last one was 6.
Yeah.
Oh, that's only good.
I don't hear you.
Wait, let me pull up on it.
Wait, they pull up, come on.
But they're gonna go where they do that.
Well, yeah, you had the person like the wood. Okay with that? Any questions? Amanda? Brianna, any questions? Right, and it is a popular question, right? They give it to the power 9 and tell you to work it out. All right. I'm not gonna rush into the Morse theorem because I want you to, besides understand the Morse, you get understand the concept of the Morse theorem,
Yes.
where you have a power and you just bring in the power here.
Oh, that's 6%.
Right, how long again now?
The 9 minutes. Making sure that class is doing well. That's what we're doing. So how long we have then, you know, like example, like
We have the Morse to do and we have the Lucas to do.
but like, you know, always like, you know, one. The opposite in one, you want more, like, specific ones is not. This is gonna be.
Yeah, somewhat. Complex always but so there's 2 questions in module 1. One whole question is integration. Part is complex, part is differentiation and integration. So just get plenty integration. 1.5 question is integration.
The differentiation, integration.
Differentiation is easy. There's something you call partial that is confusing. But it's easy.
What can you do with that?
It is easy, but that's because they're confused with implicit and partial. Integration tricky because integration is a question and a half plus a whole question in one.
So you're saying how to treat them on the one.
Integration. If you learn it.
You can treat them. We get really easy.
All right. What do we do? So